So now we're looking at the what do you think on page 199. So in this section there are 4 questions or 4 statements, and we have to decide if we agree or disagree with each one. In the first one we've got that y equals 4x minus 5 and y equals 3x minus 5. Are those the same? Are they alike? Are they the same thing? Well, there are definitely some similarities. If we look here, they both have a y, they both have an x, they both have a negative 5, but in this first one, x is being multiplied by 4. In the second one, x is being multiplied by 3. So, if we picked a number for x, let's say that x was, x is a variable, so it can represent anything. Let's say that x was 2. So we could say, if x equals 2, then y equals 4 times 2 minus 5, or y equals 3 times 2 minus 5. Well, 4 times 2 is 8, and 8 minus 5 is 3. So y equals 3 in the first case. In the second case, though, y is equal to 6 minus 5, or simply 1. So are they alike? No. In the second statement, it says that to solve the equation x over 2 plus 5 equals something, you have to subtract 5 from both sides of the equation. Well, this is definitely true. Is it the first thing we do? Yes, it is. The first thing we need to do is subtract 5 from both sides. That's going to give us x over 2 is equal to whatever we have here, minus 5, and then we still have to multiply by 2. Multiply that by 2, multiply that by 2, so that x is equal to 2 times whatever that is, that unknown, minus 5. So the question was, you have to subtract 5, or the statement was you have to subtract 5 from both sides. Well, yes, but there is something else that we need to do, and that's multiply by 2. So, yes, but. Statement 3 says that you can use y equals 25 minus x to describe an addition situation. Well, as I look at it right now, I don't see an addition. But if we take the x value and we add it to both sides, now we've got that y plus x is equal to 25. So in fact, we can use it to describe the addition of two numbers, where the sum of two numbers, the sum of these two numbers, is equal to 25. So can it be used? Yes. Finally, statement 4 says, if a graph passes through the points of 1, 3, 2, 5, and 3, 7, it has to also pass through 4, 9. Well, 1, 3 is over here, over 1 and up 3. 2, 5 is here. 3, 7 is here. And if I was to connect those points with my ruler, then in fact it does pass through 4, 9. So it does have to pass through 4, 9 if it is linear, if it's a line. And that's what we're talking about here.